Okay, so this video is going to be about factorising quadratics, but which came from a perfect square. In order to be able to see it, you pretty much need to know what a perfect square is. So let's look at a perfect square. Let's take x plus 4 all squared. This is the same as x plus 4 multiplied by x plus 4. So if you were to expand this using the times the first and the third, the first and the fourth, second and third and second and the fourth, you would end up with x squared, 4x plus 4x, 8x, 4 times 4, 16. Now if we write this out as a general form, we could have a plus b, where a and b can be anything. In this instance over here, the x and the 4. The rule is that you get a squared plus 2ab plus b squared. So we look at this, we've got x squared here, which was the a, so a squared, the 2 times a times b, so 2 times x times 4 is 8x, and we've got the b squared, so the 4 squared is 16. So this quadratic comes from the perfect square of x plus 4, and this is called the perfect squares rule. So when you're asked to factorize something, you can pretty much look for a certain pattern. And the thing that you're looking for is for your last number to be a perfect square. So 16 is the square of 4. So 4 squared, 16. So you're looking for any of the numbers. 4, 9, 16, 25, 36, 49, 64 and 81, and 100 for that matter, all being squares of the single digit numbers leading up to 10. So if this number or any of these numbers appears at the end of your quadratic in the b squared section, there's a pretty good chance that this is a perfect square and you can easily factorize it back. So if we think about, let's say x squared, let's put in 36 as our end, so we go x squared plus 36. So where does the 6 come from? It comes from, 36 comes from 6 and 6. So the bracket must have been x plus 6, s plus 6. So in this instance, we would have been looking for a 12x in between, 2 times x times 6. So you're looking at the last number, and if you see that that last number is a squared number, a perfect square, then you can factorize it back quite easily. On the other hand, you can factorize these the exact same way that you would factorize anything. You're looking for two numbers which multiply together to give the end value, but add together to give the middle value. So 6 times 6, 36. 6 plus 6 is 12. So you can factorize it the normal way. Sometimes you might get things that look a little bit different. Let's have a look. So if we had something like 4x squared, 8x, and 4, the first thing you might be saying is, well, it's got a is greater than 1. I need to be really thinking about, do I cross multiplying? How am I going to factorize this? But 4 is one of our perfect square numbers, and it's on both ends. So the square root of 4 is 2. So this is going to be 2x plus 2. And if it's a perfect square, then the other bracket would be 2x plus 2. So you can just check that. 2 times 2 is 4, 2x, 2x, 4x. We've got 2 times 2x is 4x, 2 times 2x is 4x, 4x plus 4x is 8x. That was Timmy. Okay, and so you end up with the factors. So again, if you see a number which is a perfect square, that's what you can look for, but you can still cross multiply this to get your factors. You don't need to use the perfect squares. It is sometimes a little bit quicker in order to factorize, or to see the patterns, but not necessary. Enjoy!